crypto system make use of 2 public key and 1 private key. RSA, RABIN as well as ELGAMAL crypto systems are very important. You can expect these questions for 5 marks or 7 marks or 8 marks. Now this public key is used by the many user. At the same time, Alice is going to use the public key E1 and E2. Hello to all, a warm welcome to my new session on asymmetric key cryptography. I am Revati from the Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. So dear student, let's see which are the topic I have covered in my last session of this unit. There I started about introduction, that is introduction about asymmetric key cryptography. Along with that, I have covered key, along with that the example for asymmetric crypto system. So that is RSA algorithm along with problems. These are the topic I have discussed in my last session of this unit. But in my today's session, I'm going to deal with RABIN crypto system as well as ELGAMAL crypto system. And these two are the example for asymmetric crypto system, and the most commonly used asymmetric crypto system is RSA algorithm. And from the examination point of view, RSA, RABIN as well as ELGAMAL crypto systems are very important. You can expect these questions for 5 marks or 7 marks or 8 marks. Now, directly I'm going to begin with today's topic, RABIN crypto system. So what is this RABIN crypto system? If I consider RSA crypto system, it is mainly based on modular exponent. But this RABIN crypto system is mainly based on quadratic exponent. So here the RABIN crypto system can be thought of as an RSA crypto system in which value of E and D are fixed. So here the RABIN crypto system is same as RSA crypto system. But what's the difference here? If I consider RABIN crypto system, so here if I consider RABIN crypto system, here E, that is public key as well as D, that is private key, are fixed. So if I consider RABIN crypto system, private key as well as the public key are fixed, and the encryption formula here is ciphertext equal to plaintext to the power 2 mod n, and the decryption algorithm here is, see the difference, it is 1 by 2. So ciphertext to the power 1 by 2 mod n, and this is the overall RABIN crypto system. And if I consider RABIN crypto system, once again I'm going to have key generation algorithm as well as encryption key as well as decryption algorithm. Now if I consider this diagram, see here I'm going to have the key generation algorithm. That means if I consider any cipher algorithms, there we are going to come across 3 parts. One is key generation algorithm, encryption algorithm as well as decryption algorithm. So here this RABIN crypto system is mainly based on the quadratic residues. So here if I consider this example, I'm going to have the sender and I'm going to have the receiver. This is all about sender part and this is all about receiver part. And here the receiver is responsible for generating public key as well as private key. So what is the key generation algorithm I'm going to have here, at the beginning they have to select P and Q, and P and Q must be prime numbers. By using that, they are going to calculate n value. So n value purely depend on P and Q. Now the receiver is going to generate two key, public key as well as private key. So after generating public key as well as private key, what they are going to do, they are going to keep private key for their reference, and they are going to announce public key public to the user. That means more than one user they can able to use public key. For that reason, I'm going to have the arrow mark. Okay, so now the same public key is used by the Alice. Now Alice is going to apply encryption algorithm. So what Alice is going to do? Alice is going to apply encryption algorithm. So what is the input to the encryption algorithm? That is plain text as well as the key. After applying encryption algorithm, Alice is going to get the ciphertext, and that is given to the, or that is sent to the receiver. And at the receiver side, Bob is going to receive ciphertext. Now Bob is going to apply private key as well as decryption algorithm. Okay, now Bob is going to have ciphertext as well as decryption algorithm with key. Now he is going to get the plain text, and in middle you can able to access, or you can get the information about ciphertext, and by using ciphertext he may try to extract the plain text as well as key. So this is all about RABIN crypto system. So dear student, if I consider RABIN crypto system, it is made up of three components, that is key generation algorithm, along with that encryption algorithm as well as decryption algorithm. So here first, if I consider key generation algorithm, what is the first step? They have to choose two prime number P and Q. Okay, and it must be in the form of 4k plus 3, and P and Q are not equal. So it must be whatever the number I'm going to choose, that must be in the form of 4 into k plus 3, and I'm going to find n equal to P into Q, where n is my public key, whereas private key is nothing but my Q and n, and I'm going to return public key as well as private key. Now I'm going to announce public key public to the user, whereas private key is kept secret. And if I consider encryption algorithm, see what are the parameters I'm going to have in my encryption algorithm. That is plain text, and I'm going to find the plain text to the power 2 mod n, and I'm going to return the ciphertext. Now if I consider decryption algorithm, see here in RABIN crypto system, I'm going to make use of Chinese reminder theorem. So dear student, in my RABIN decryption algorithm, if I apply decryption algorithm for the given ciphertext, then I'm going to get 4 different plain text, and in that I want to identify particular plain text. Okay, and it is very difficult procedure. For that, what I will do, I'm going to use Chinese reminder theorem in order to overcome the confusion. That means which one is the correct plain text, and it's very difficult to select. Okay, to overcome that, we are going to use Chinese reminder theorem. Now see here, I'm going to get A1, A2, B1, B2. These are the 4 plain text. Okay, now in that plain text, I want to get my original or proper plain text. So what I will do, I'm going to find out P1, P2, P3 as well as P4. Okay, now what is the input to this Chinese remainder theorem, that is nothing but the different congruence equation. So I'm going to have the different congruence equation, and it is mainly used to get the plain text. So this is all about RABIN crypto system as well as key generation algorithm as well as encryption as well as decryption procedure. Now, moving further, I'm going to have ELGAMAL crypto system. Now, I'm having RSA algorithm as well as RABIN crypto algorithm, that is crypto system. Along with that, I'm going to have one more public key crypto system that is named as ELGAMAL. Okay, what is this ELGAMAL? It is mainly based on discrete logarithm problems. So here ELGAMAL crypto systems are mainly based on discrete logarithmic problems. Now I'm going to have the key generation algorithm as well as encryption as well as the decryption procedure. Now these three are the components of ELGAMAL crypto system, and as I discussed, it is mainly based on the logarithmic procedure, that is discrete logarithmic procedure. So to generate key, I'm going to use P and I'm going to select E1, and while selecting E1, I'm going to use discrete logarithmic equations. So I'm going to use primitive root and I'm going to select D. Okay, see here, I'm going to have two public key and one private key. In ELGAMAL crypto system, here only I'm going to have two public key and both the public keys are used to encrypt the plain text. Okay, fine. So here I'm going to have E2 equal to E1 to the power D mod P. Here E1 and E2 are my public key and ELGAMAL crypto system uses two public key. Okay, now after generating public key as well as private key, the private key is kept secret and the public key is announced public. Now this public key is used by the many user. At the same time, Alice is going to use the public key E1 and E2. Now Alice is going to have the plain text and she is going to perform encryption algorithm with the help of E1 and E2. After performing encryption algorithm, the ciphertext is sent to the receiver. Now the receiver Bob is going to receive the ciphertext and now he's going to apply decryption algorithm in order to get the plain text. So this is the way the ELGAMAL crypto system is going to work. Now I'm going to have the key generation algorithm. So dear student, this is very important because you're going to get the questions like explain ELGAMAL crypto system or RABIN crypto system or RSA crypto system. In that you want to write the diagram along with you want to explain the particular topic, then write the component of all the algorithms like key generation algorithm, encryption algorithm as well as the decryption algorithm. So here first I want to select a large prime number. So what is my first step here? I want to select a large prime number and select D. I want to select D. D must be grouped in such a way that so Z of P star, that is X. So here D must lies between 1 and P minus 2. Now I'm going to select E2. So E2 must be a primitive root and that comes between this formula, that is G equal to ZP to the power star comma X. Now, dear student, I want to find out E2. So, what's the formula used to find out E2? That is e to the power d mod P. And I'm going to get the public key E1, E2 and P. So, dear student, please remember here that in only ELGAMAL crypto system make use of two public key and one private key. And this algorithm is going to return public key as well as private key. Moving further, I'm going to have the encryption algorithm as well as decryption algorithm. Let's see what are the parameters used by the encryption algorithm. That is E1, E2, P and P. So here P is plain text where this P is nothing but the prime number. Now select a random integer R. Okay. Now I want to select a random integer R. Now I want to get my ciphertext 1 because I'm going to use two keys. Okay. Two public key to encrypt the text. So if I use first public key, then I'm going to get first ciphertext. And if I use second public key, then I'm going to get second ciphertext. So here e to the power r, that's nothing but the random number mod p. So I'm going to get my ciphertext 1 and plain text into e to the power, that is e to the power r and mod p. I'm going to get my second ciphertext and this is the return value. So what are the return value of an ELGAMAL crypto system? That is C1 and C2. This is the ELGAMAL encryption crypto system's return value. Now, if I go with ELGAMAL decryption, see here the parameters of ELGAMAL decryption. So here I'm going to have 4 parameters. So D is nothing but my private key, whereas P is nothing but prime number and C1 and C2 are nothing but public key. Okay, then I'm going to get the plain text. That means after applying decryption algorithm to the ciphertext, I'm going to get the plain text. This is the way the ELGAMAL crypto system is going to work. So, dear student, from the examination point of view, both ELGAMAL crypto system, RSA as well as RABIN crypto systems are very, very important. Okay, all these are very, very important from the examination point of view. So, dear student, in my today's session, I started with RABIN crypto system as well as ELGAMAL crypto system. But in my next session, I'm going to deal with new unit named digital signature. So, dear student, don't forget to watch my next session because there I'm going to deal with digital signature. So, dear student, in my today's session, you got more information about asymmetric key crypto system. So let's meet in the next session with more information about digital signature. Until then, keep watching and keep learning. Thank you.